Every deep space tracking station on Earth just detected the same impossible event. 3. Atlas, the interstellar visitor that's been defying physics for months, executed a controlled burn that changed its trajectory by 11 degrees. And its new course is aimed directly at Earth. This wasn't gravitational drift. This wasn't a navigation error. Multiple independent observatories confirmed what should be impossible. The object-fired propulsion systems maintained thrust for 47 minutes and altered its path with precision that would make our best spacecraft engineers jealous. The math is terrifying. Atlas was on a trajectory that would have taken it past Earth at a safe distance of 15 million miles. Now, it's on a collision course that will bring it within 240,000 miles of our planet, closer than the Moon. And at its current velocity of 130,000 miles per hour, we have less than 4 weeks before it arrives. The thing nobody tells you is that objects don't just change course in deep space. Not without propulsion, not without deliberate navigation, and definitely not with the kind of precision that suggests whoever or whatever is controlling Atlas has been planning this maneuver for a very long time. NASA held an emergency classified briefing hours after detection. The Pentagon activated crisis response protocols, and for the first time in history, the phrase planetary defense scenario has moved from theoretical planning to active operations. The trajectory change didn't happen gradually. It was instantaneous, coordinated, and executed with mathematical perfection that our most advanced spacecraft couldn't match. Thermal imaging satellites detected a massive heat signature from Atlas. The object's surface temperature spiked by 4,000 degrees Celsius in less than 1 second, then 2 seconds. Temperatures that would vaporize any natural comet instantly. But Atlas didn't vaporize, it accelerated. A senior astrophysicist at the Jet Propulsion Laboratory described what the data showed. We detected exhaust plumes from multiple points on the object's surface, firing in perfect synchronization. The thrust vectors were precisely calculated to change velocity and direction simultaneously. This is spacecraft maneuvering, not natural phenomena. There's no longer any ambiguity about what we're looking at. The burn lasted exactly 47 minutes. During that time, Atlas maintained constant acceleration while adjusting its orientation to keep those thrust vectors optimally aligned. That kind of precision requires gyroscopic stabilization, real-time navigation calculations, and propulsion systems that can throttle smoothly across nearly an hour of continuous operation. For comparison, when NASA adjusts spacecraft trajectories, the burns last seconds or minutes and require months of planning. Atlas executed a maneuver that changed its trajectory by millions of miles, did it in less than an hour, and did it with zero advanced warning or preparation time that we could detect. The energy requirements are staggering. To accelerate an 800-meter object to the velocity change we observed requires roughly 500 trillion joules of energy, equivalent to a 120 kiloton nuclear explosion, except channeled entirely into controlled thrust instead of destructive blast. A propulsion systems engineer broke down the implications. We're looking at either nuclear propulsion, antimatter drives, or something beyond our current understanding of physics. Chemical rockets couldn't deliver this kind of sustained thrust. Ion drives couldn't generate this much power. Whatever technology is powering Atlas is decades or centuries ahead of anything we've developed. But here's what's really disturbing. This wasn't maximum thrust. Analysis of the exhaust signature suggests Atlas was operating at approximately 40% of its apparent capacity. It changed its trajectory dramatically while barely straining its propulsion systems. That means it has capability in reserve for additional maneuvers. The new trajectory isn't random. It's not even close to random. Atlas has positioned itself on a path that will bring it to a precise point in Earth's orbital space. And that precision reveals intent that can't be ignored. Current calculations predict Atlas will enter Earth's gravitational sphere of influence in approximately 27 days. But instead of flying past like its original trajectory, it will now decelerate to match Earth's orbital velocity, effectively parking itself at a distance of 240,000 miles, roughly 60,000 miles closer than the Moon. An orbital mechanics specialist explained the significance. That distance isn't arbitrary. It's outside the Hill sphere where Earth's gravity dominates, but close enough for detailed observation with relatively simple optics. It's also the perfect distance for deploying smaller craft that could reach Earth within hours rather than days. Tactically, it's the ideal position for someone planning extended operations near our planet. The approach path is equally revealing. Atlas will arrive from the direction of the Sun, meaning Earth-based telescopes will have difficulty observing its final approach due to solar glare. It will also pass through the plane where most of our satellites orbit, giving it optimal positioning to survey our space infrastructure. But the most disturbing detail, the trajectory puts Atlas in position during a new moon when Earth's night side will be at its darkest. Maximum visibility for observing our cities and infrastructure without the interference of lunar reflection. A military space analyst described the tactical implications. If I were planning reconnaissance of Earth with the goal of remaining undetected as long as possible, this is exactly the approach vector I'd choose. Sun angle for concealment, optimal orbital plane for satellite observation, and arrival during maximum darkness. This isn't a random path. This is operational planning. The timing also coincides with several other factors that seem too convenient to be coincidental. Major spacefaring nations will have minimal satellite coverage of the arrival point. The International Space Station will be on the opposite side of Earth during closest approach, and solar activity forecasts predict minimal interference with communications and sensors. Remember those 5 metallic Escort objects that have been accompanying Atlas since we first detected it? They're moving too, and their new formation is decidedly more aggressive. Within minutes of Atlas's trajectory change, all 5 escorts executed synchronized maneuvers of their own. They've abandoned their protective pentagon formation and spread out into what military analysts immediately recognized as an offensive screen pattern. A former Air Force officer with experience in space operations described what they're seeing. The escorts have positioned themselves in a forward-deployed configuration. 3 objects form a leading edge with 2 in overwatch positions behind and above. This is textbook assault formation. You put your offensive assets forward and keep your support elements in protected positions. We use this exact pattern for strike missions. The escorts are now positioned between Atlas and Earth, maintaining a spacing that allows overlapping fields of fire while preventing multiple objects from being engaged simultaneously. It's a formation designed to maximize offensive capability while minimizing vulnerability to counterattack. But there's something else happening that's even more concerning. Each escort is now emitting powerful electromagnetic fields far stronger than the mathematical broadcasts they were transmitting before. These fields are strong enough to deflect incoming objects, potentially including missiles or kinetic impactors we might launch in defense. A weapon systems engineer analyzed the field strength. Those electromagnetic signatures match the profile of active defense systems. They're generating fields that could deflect or destroy incoming projectiles. It's like they've activated shields, and the power levels suggest they could maintain these fields indefinitely while still having energy available for offensive operations. The escorts have also deployed smaller objects, dozens of them. These meter-sized units have spread out from the main formation and positioned themselves along the approach trajectory, creating what looks suspiciously like a relay network or early warning system. The thing nobody tells you is that these smaller objects are positioned exactly where you'd place sensor platforms if you wanted to detect any launches from Earth. They're monitoring us while the main formation approaches. It's surveillance architecture, military grade. This isn't the first time we've detected an object changing trajectory in space, but previous incidents were either our own spacecraft or natural phenomena that had explanations. Atlas is different, and comparing it to past events makes the current situation even more alarming. In the early years of the space program, both the United States and Soviet Union detected objects that appeared to maneuver. Most turned out to be tracking errors or misidentified satellites, but a handful remained unexplained, including several cases where objects changed velocity in ways that required propulsion systems. A former NASA analyst described one incident from the Cold War era. We tracked an object that accelerated without any visible exhaust or energy signature. It changed course 3 times over a period of weeks, always moving to avoid our observation satellites. The case was classified and officially attributed to solar wind effects, but the math never supported that explanation. Something was actively evading our tracking systems. The difference with Atlas is scale and obviousness. Previous unexplained maneuvers were subtle, small velocity changes that could be dismissed as measurement errors or exotic natural phenomena. Atlas just executed a burn that's impossible to misinterpret. It's as if whoever's controlling it decided that stealth no longer matters. There's also the case of Oumuamua, the previous interstellar visitor that accelerated as it left our solar system. A Harvard astrophysicist suggested it might be artificial, a claim that sparked fierce debate. Now, with Atlas demonstrating obvious propulsion, those previous arguments seem prescient rather than controversial. A research scientist who studied Oumuamua's trajectory explained the connection. We detected anomalous acceleration, but couldn't prove it was artificial because the effect was subtle. We could construct natural explanations that fit the data, even if they required unlikely conditions. With Atlas, there's no natural explanation. This is deliberate maneuvering using advanced propulsion. It validates everything we suspected about Oumuamua, but couldn't definitively prove. The pattern is troubling. First, a subtle visitor that might have been artificial. Now an obvious one that leaves no doubt. It suggests escalation, as if first contact is being attempted in stages. First a probe to test our detection capabilities, now a more obvious approach to gauge our response. The trajectory change itself is a demonstration of technology that should terrify and fascinate us in equal measure. Analyzing what Atlas just accomplished reveals capabilities that reshape our understanding of what's possible. The precision of the maneuver indicates navigation systems that can calculate orbital mechanics in real time with accuracy that exceeds our best supercomputers. Our spacecraft require ground-based support for complex navigation. Atlas is apparently doing all calculations on board while accounting for gravitational influences from multiple planets, solar radiation pressure, and relativistic effects. A guidance systems engineer explained the computational requirements. To execute that maneuver, you need to know your exact position and velocity to within centimeters and millimeters per second. You need to predict how every gravitational field in the solar system will affect your trajectory, and you need to adjust thrust vectors in real time to compensate for any deviations. The processing power required is orders of magnitude beyond anything we've built. The propulsion technology itself represents a paradigm shift. Whatever drives Atlas can generate massive thrust while maintaining smooth, controllable acceleration across nearly an hour of operation. It doesn't use chemical rockets. We'd see the exhaust signatures. It's not solar sails. The acceleration is too rapid. It's something else entirely. Some researchers believe it's a fusion drive using nuclear fusion to heat propellant to extreme temperatures and achieve high exhaust velocities. Others suggest antimatter propulsion, where matter-antimatter annihilation provides virtually unlimited energy density. A few even propose exotic physics, manipulating space-time itself to generate thrust. Whatever the mechanism, the energy density is profound. Atlas carries enough fuel or power generation capability to execute major trajectory changes while maintaining all other systems. Life support if it's crewed, communications, defensive shields, sensor arrays. That suggests either incredible fuel efficiency or onboard power generation that makes our nuclear reactors look like campfires. But perhaps most revealing is what the maneuver tells us about intent. Atlas could have continued on its original trajectory, observed Earth from a safe distance, and departed without ever revealing its artificial nature. Instead, it deliberately changed course in a way that's impossible to misinterpret. It's announcing itself. It's saying, we're here, we're intelligent, and we're coming closer. Every major military on Earth is now on high alert. And the response patterns reveal that defense establishments are treating Atlas not as a scientific curiosity, but as a potential existential threat.